Okay, for those of you who missed the lessons last week, this might help a bit. First of all, we looked at what lines of latitude are. They are, if you've got the Earth, that's the Earth, the lines of latitude are the circles that go around horizontally, if you like, going around and the tummy of the Earth. So the equator is the biggest line of latitude. All the others get smaller going north and get smaller going south, as if you're putting elastic bands horizontally around the Earth. Now, Ibstock is somewhere about there on the Earth, and our angle of latitude depends on which line of latitude we sit on, and the angle of latitude is measured like that, as an angle from the centre. Right, now let's just quickly look at what happens on the vernal equinox. Let's rub that out. So on the vernal equinox, there's the Earth, there's the equator. The sun's rays are coming in at 90 degrees to the equator at midday on the vernal equinox, which was Friday the 20th of March. Obviously we're up here somewhere, so if I was standing up at Ibstock, I know that makes me look really tall, the sun's rays are all coming in parallel, so although they hit the equator at 90 degrees, they don't hit Ibstock at 90 degrees. Now let's just zoom in a bit closer. So if there is something standing upright at Ibstock, the sun's rays are coming in like this. There will be a shadow on the ground there, because the object, me or a post or something, is stopping the sun hitting the ground at that place. If it's an upright object, there'll be a right angle there. If I measured the height of the object and the length of the shadow, can you see I would have two sides of a right angle triangle? And that would enable me to find this angle here. If I draw that triangle out, if there's the height of the object, and there's the shadow on the ground, and there's my right angle between vertical and horizontal, I could find that angle there. I would have the opposite and the adjacent, so I would use tan. Now what you need to think about now is why it's that angle that helps us find the latitude of Ibstock. So let's look at that a bit more closely. Right, so again, let's go back to the Earth. There's the centre of the Earth, making an angle of latitude from the 0 line. The equator is at 0, and we're somewhere between 0 and 90. This angle at the equator, if I had somebody standing upright on the surface, can you see? Because the sun's rays are coming in at 90 degrees to the equator, they join on exactly to this dotted line to the centre of the Earth. Then if you go up from this way, from the centre of the Earth up to Ibstock on the surface there, and carried on, as in a person or a post standing up, that makes a straight line from the centre of the Earth to there. These sun's rays are parallel, this one and this one, so that angle will be the same as that angle because they are alternate. Like our parallel lines rules, that angle is the same as that one. That angle is the same as that one. And so if we find this one, we will have found the angle of latitude at the centre. I hope that helps a bit. Best of luck. Don't worry too much if you don't get it too much, because it's a bit difficult to do it remotely. But have a go. That's the most important thing. Okay, good luck.